They are getting quicker. $20. Winnable. Hello and welcome. In this video, we're going to be creating Space Invaders in Pygame from scratch using AI. And the goal here is going to be to use the GitHub Copilot Chat extension, which is probably the most user-friendly coding AI thing out there, to write like 90% of our code. The way that this is going for me so far is, well, mixed. This is the third time I'm attempting to write this game. The first time was this morning during a live stream, and I'm going to actually share my progress so far. Now take a look at this. In the live stream, actually, we managed to get the basics pretty far. In about half an hour, I managed to create this game, which had shooting. The enemies had lives. But the second that I got into trying to create explosions, essentially the confidence of the AI saying this is the solution sort of put me off on the wrong track. And I spent, say 35 to 45 minutes making this and another 45 minutes being lost and getting nowhere with explosions. So then without a recording, I went into version 2 and tried to create the explosions. I managed to do this. In the process of doing it, I reformatted everything to be fully object-oriented, including game.py. And this is what the explosions version looked like. I decided to go 60 frames a second, and that makes everything move a lot faster. It's a bit more challenging. And after you get 10 of them, you win. Of course, it should be very, very easy to basically, have more enemies, add different kinds of enemies, and have some other winning condition or make them go faster. But this is the second version, which I'm really quite happy with. It took me a lot of trial and error to essentially figure out how to draw this sort of scattergun effect, this explosion. But I managed to do it entirely within GitHub Copilot Chat. It does hallucinate, when you try to do more advanced features, it does hallucinate a lot of code. For example, it asks you to use a lot of functions that don't exist. So it's a little finicky. And so now we're in version 3. And I'll just show you what we have in version 3, which is basically nothing. All our files exist only in comments. And we're going to try to use those comments to create boilerplate code, because we are starting this game with just a general idea of how things are supposed to work. The best advice I can give you when you're developing games with anything is to try to come up with stages in which you're going to develop your game. So essentially what we're going to try is we're going to try to have just the player who's then shooting the bullets. First of all, the player who's moving, then the player who's shooting bullets, then one enemy that is there, and then multiple enemies. And then we add the explosion, and then we can add the scoring and the game over. So essentially, that's kind of going to be the way we move through this game. And we're going to have to be very careful with how we prompt the Copilot Chat. Now, one thing you might be wondering, like, why not use GPT-4? Why use Copilot Chat? Now, GPT-4 is most definitely better. I've had GPT-4 create much more difficult applications from zero. But Copilot Chat is 20 times faster, and it's also built into VS Code, which is so much more convenient. So yeah, if you can learn how to code with Copilot Chat confidently, I reckon you're going to sort of have a very, very massive productivity boost. So let's give this a go, shall we? Let's start with the game.py and the hero class. If we have sort of the comments here, use the highlighted comments. Use the highlighted comments to create Pygame code for hero class. When the context window is tiny, meaning that when you have very little to do, it tends to really excel. Like these are going to go down perfectly. I think, this is kind of why it gets you in a lull. Essentially, start getting very careful when it needs to work with, say, 100 lines or more. But this looks pretty good. The hero class has got XY, it's got XY speed, it's got a width and height. I'm not sure about a height being like 50. I want it squashed. I want the height to be 20. Color white, whatever, you can have it any color. Let's RGB. Let's make it purple. So yeah, that's a hero. So now in the game, let's try populate the game.class. Use the highlighted comments to create the game class. However, do not create any enemies yet, or any bullets. Just the hero at this point. The game class. Okay, I think we can attempt this, and then it's probably going to be missing a bunch of boilerplate code that we're going to need to add. Excuse me while I just like move the camera like a tiny bit down. I think, yeah, I think that's good. All right. I kind of dig this object-oriented approach of like handling events, update. It still draws the hero. It says hero and arrays, so it's sort of already including the arrays, and it's including the debris, and it's including everything. And this is the problem with AI development. It really, like, this is missing a bunch of stuff, right? Like if I paste this, it's going to be, you're going to see so much red, actually. Way less red than expected. But we don't have any enemies. I might as well fix the ray class. Using the comments, create the ray class. And I'll try to get rid of the enemies and try to just have the hero that's shooting using the highlighted comments, write the ray class. It's probably about as easy a class as you can have. Let me just see if it draws the surface height. The height needs to be like it's a beam, so maybe like 320. Y speed should be 0. Sorry, X speed should be 0. Y speed -10. That makes perfect sense. I'm importing Pygame twice, so I'm just gonna get rid of that. What I really want to do now is take a look at self.hero. Okay. Take a look at the imports. I will leave this there. Leave the comments. Yes, from hero class import hero. From ray class import ray. From enemy class import enemy. It doesn't exist. Enemy and debris do not exist. So let's see if we can, where the enemy is. Self set X speed. We're not having any setters. Now, setters are sort of best practice to set speed. So where is my hero? We could create this method. Doesn't hurt, since they already want us to have it. Yep. And self.xSpeed equals to speed. Now, does it have, see, it doesn't even have that self.xSpeed, but we already are starting with it. Fine. So we're going to have 10 and -10 here. Let that happen. Let that happen. We're going to shoot array. We have created array. That's fine. Key up. the set.x speed is going to go to 0. That's fine. Update the hero and raise. Update the debris. Update enemies and check collisions. All right. I will update the debris can pass as well. Draw everything. Fill the screen with zeros. For rain, self-raise. For debris and self, the debris list. Now, do we have a debris list? If it's empty, it should be fine. Self.debris list. I can leave you there. You exist. Draw score. Do we have even draw score yet? I don't think so. We can have it in the future. Or maybe self.draw score. Def draw score. I think you're going to need to draw it on the screen, but whatever. Why are you underlying yourself? Obscured by the declaration of the same name. Three times. Oh, it's already there. Ah. All right. Let's run this thing. Cannot import hero from hero class. Did I not press save? Let's try this again. Hello from the Pygame community. Okay. I am convinced that we're missing like boilerplate code here. So for example, do we have screen, right? Screen equals the Pygame display, screen width, screen height. So we didn't even have the screen. The game itself kind of, let's see the class, self.score, draw everything. Like you still need to run the game. Like all of these things, you need to create a game object. Handle events. Like you need to create a game object. So like if I said def run, it would probably have some idea. Yeah, run self while self game on, do that. And then pygame.quit. And so now we could say like game equals the game, and then we can say game.run. So maybe now we're gonna get something. My God. So this is the power of coding with AI. How many minutes are we in? 13 minutes. 13 minutes. We've already got like an OO skeleton. There's a few things to troubleshoot. Like we're definitely way too high. So if we go into the hero class, we can try to find the location of this guy. Where is he being drawn? Self.x, self.x, self.x. Probably X is instantiated in here. Self.hero. 100. Just move him like 40 off the bottom. Let's try that again. Now, one thing that I have to wonder, like try using the same prompts as me. To what extent, in theory, it should be 0 because the way that this is GPT-3. It's got 2000 token context window. It's impossible that it's reading even 30% of the previous files. So all of this is being generated based on other people's Pygame code on the internet, which kind of outlines some best practices. I'm sure that this model was trained on best practices. So I've never expected to be this far along in 15 minutes. So we can take it slow, easy, and try to explain some stuff. But right now we are already essentially having this OO structure. We are shooting. Now we can start creating enemies. So let's take a look at the enemy class. I'm going to highlight this. I'm going to say, using the highlighted comment, create the enemy class. This is all boilerplate and straightforward other than the collision. There's so many different ways to handle collisions that we're really going to need to be careful. Let's take a look. So it created a life of 3. Let's give it 5 bullets. Color. They're red. Do we want them to be red? They're supposed to be green. Okay. It draws itself, self.width, self.height, blah, blah, moves itself. Now the X speed should be nada. X speed is 0. That's nice. So everything about it pretty much already exists. We just need to make sure that it's instantiated. Self.width, self.height. Okay. There is something that I do want to change here. And I do want to say, I want to say if it's dead. So you can return true or false here, but when it collides, when the enemy collides with something, it's going to be a bullet. We could say self.life minus equals 1. And def is dead. Yes. So if self.life is less than 0, it will return true. Otherwise, it'll return false. So now we can sense the collision and also know when the enemy is dead. If it collides with anything else, it will return is dead. Okay. Now we can use this to basically get rid of this enemy object from the list of enemies, right? So we have hopefully got a list of enemies, self.enemies. The list is right here. We're going to need something inside the game, update enemies. So maybe here, all right? We're going to need to start using, spawn an enemy every 2 seconds. Great. Tick, 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 tick. And see what I mean by hallucination. Like, I don't have this thing. Like, what is spawn enemy? Don't have it. So, I can just start with self.enemies, append self.enemies.append. And again, why does it insist? Do I have the enemy thing? Oh no, because I haven't even imported from import enemy. So maybe this time the auto suggestions are going to be useful. Okay. Enemy. Oh, look at that. All right. So we want to make it random where it appears. So we can import. I'll import random here. And the width. So I think this is the X. Do I specify the enemy speed? No, the enemy speed is already known. That's what I'm talking about. Enemy random.random and then the append. Really? Okay, the actual enemy needs a comma 0. done it? No, that append is there. It's comma 0 here. Great. So just to specify, x equals to that. And y equals to that. Comma y equals to that. That should be helpful. So if we look into the enemy class, it only takes x and y here, so we should be able to spawn an enemy. And we've created this Pygame that get ticks self.enemy timer. Do we have enemy timer? Okay. It created that. Very, very good. All right. Let's run it. Cannot import enemy from enemy class. Really? Because we didn't press save. Okay, let's try that again. Ding dong. All right, 2 seconds. I'm still waiting. No enemies. All right, so I believe I'm creating them, but they're not getting animated. They're drawing everything. I don't think it draws the enemies, and I'm not sure we're animating them either. So draw the enemies. For enemy, self.enemies, enemy.draw, self.screen. Great. Wow. Do we have self.screen? Is that? We do. So we've got screen and self.screen. I need to only use one of those because that's going to be an issue. Screen. Let's find all of the instances of the self.screen. That's good. Self.screen, 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 self.screen. No, we're good. I think we're good here. Okay. So we have drawn the enemy, I believe. Great. Now, that draws everything. And then we need to enemy.move. So update all the enemies. For enemy and self.enemies, you better show me enemy.update. Really? Enemy.move. I don't have a function called update. Now we're going to need to check collisions as well, but let's not worry about that until I know that the enemies are actually on the screen. Oh my God. They're flying too fast. Okay, this is not acceptable. Enemy class, enemy class, enemy class, enemy.y speed. Make it 1. How about that? Given that we're only setting x and y, this should make them go slow. What? Did I not save this thing? Enemy class, save. Move. Self.y plus equals. Great. We create the enemy. X equals that, y equals 0. Is there any enemy speed anywhere? No. Run this again. Why are my enemies fast? That's like, thankfully. Okay. So now we've got enemies, and I think it should be very, very straightforward to just run over each of the enemies and each of the rays and then check if they collide. Let's do that. If I can find the enemies. All right. I think we just go like for ray and self.rays, if enemy. Okay. So if the enemy collides with ray, we do not want to remove the enemy. No, no, sir, no, no, no. We don't want to do that. And we don't want to do that. We just want to do that. And we can say if enemy dot is dead. Thankfully. we can remove it, and we can increase the score. Okay. Hopefully, the enemy life is subtracted inside the enemy method. A lot to keep track of when you're developing it like 10 times the speed. Okay. Check collision. Sense. What a good comment. Thank you very much. You hallucinate all the wrong code, but then you tell me that you hallucinated it. One thing that I'd really want to hear from you guys in the comments. How alarmed are you by these confident suggestions of AI that turn out to be wrong? I mean, argument must be a rect style object. What do you think array is? Self.raise. Let's see if we are appending to self.raise. So when we press space, right, we create an array and we append to it. And I'll save this guy. And if we go into array class, it's a rect style object. So I don't see a problem. Other rect. Let's take a look at this and think about it for a second. No. This is an object. Why don't we just specify other array and then see other, and we can try pygame.rect other array.x other array. Aha. So we are temporarily creating this other rect here. Whereas this just assumed that the object was a rectangle. So this might have fixed it. Well, it didn't crash instantly. Self.life -1. What is your problem? Enemy class line 30. We create the other rect. There are no errors here. Let's just print got here alive. All right, let's see if that prints when we shoot. It got there alive. Okay. That is interesting. It creates the other rect. No, we are reducing its life by 1 too early. This should be an if, right? Then self.life -1. So, and then you can return true. If this collision doesn't happen, you return false. I knew it. I was absolutely certain that if this was going to go south, it's going to go south with the collisions. They're tough. Look at that. What's the time on the clock? 29 minutes. Okay, half an hour. Last time I got here, frankly, in about the same amount of time, maybe 35, 36 minutes. So I'm not sure I'm getting a lot better, but you know what we can do? We can add some assets. So I can just say in the enemy class, can you use the, let's see, the file explorer inside assets, 𝗦𝗦𝗧𝗦𝗦. Can you use the 𝗦𝗦𝗧𝗏𝗔 image inside the assets folder to show the invader? The thing that I love about it is, like, I don't remember that screen.blit, like it's some highly specific Pygame command. Self.image, right? It's decided to do it with ospath.join. I don't think we need that, but let's do this. I'll copy this. I'll go into the enemy class, and it adds them here. And I'm just wondering, what if I just did like assets, that? Could that just work? So we've created that self.image there, and in the draw it becomes something else. It becomes surface.blit self.image. Okay. There you go. Okay. Let's try to do the same for the player. So hero class, bingo bongo. You get rid of this whole OS crap. Yeah. Assets hero.jpg. I think it was hero2. And then there was screen surface.blit. One thing that I keep wondering though, surface. It's a parameter of the draw, so you're going to draw to the screen. That's what the surface is going to work. Okay. Save this. Not searching for nothing. Go to game, run. Pew! Okay. So now for the hardest part, which is going to be creating the explosion. So the initial way, the way that Copilot Chat got me completely screwed the first time, was it suggested that I create two classes. One was class called explosion. Funnily enough, if you use the term explosion, it's going to refuse to generate any code. So we're going to need to call it like boom or something like that. But the key thing that came out of it was to use this debris class. And so instead of actually having an object for an explosion, we're just going to create a collection of debris and then we're going to scatter them. So using the comments that are highlighted, create the code for the debris class. Now, I'm not sure the self.kill thing. There is something about Pygame objects where self.kill doesn't always work. But let's play around with, yeah, let's play around with this. Like, if self.lifespan is less than 0, so they're reducing their own lifespan by -1. Yeah, it says remove from the debris list. Let's not even do that, right? Let's just do that. And the lifespan is 60, so 60 frames. If we're running at 60 frames a second, are we running? I don't know, maybe we're running at 30. No, we're running at 60 frames a second. So what we need now is to create 10 or 20 or whatever, how many ever pieces of debris, and scatter them in various directions. This is very good. It's already giving it a random direction. So we just need to create, like, let's say 20 of them and move them, draw them, move them. Okay. So where is the code where we remove the enemy? Right here, right? Let's just, for ein range 20, go 20. Why did you autofill with no I? All right. Thank you very much. This guy needs an import. So, sell the debris list, debris there. Now we got 20 of them. We still got to draw them. Ah, we're already drawing them. That's very nice. Do we update them together? Update enemies and collisions. Oh, we have a thing here. How nice. For debris and debris list, debris.update, if debris y.screen height. No, don't worry about that. Don't worry about that. Boy, could this be done? One, two, three, four, five. Whoa, they're white. Ah, this is awesome. This is awesome. This is awesome. I love it. We got to give them a different color and maybe make them a slightly smaller size, but let's go into the debris. It's drawing circles, radius 5. Let's go radius 3. And self.color, let's give it sort of like a palish red. So that's red. Give them 55. 55. All right. Boom. Oh man, this is so good. That is bloody ace. Ah. So we're going to need a winning condition. We're going to need to win at 10. But that shouldn't be too hard. I bet it's already created game 1, game over. Great. All right. So now's for like a little bit of housekeeping. 40 minutes. I'll aim to finish by 50. Okay. It's already drawing the score. So now look at the main file. It's going to know what I mean by main file and set the game over to true when an enemy reaches the bottom of the screen. You better know what that is. All right, let's see. Ding, 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 ding. If enemy self.screen height. Do we have screen height like a thing here? No, we don't. It's a constant at the top. 800 by 600. All right. Update enemies. Enemy. Blah, blah, blah. I mean, we could do it right here. If enemy, bing, bing, bing. Don't worry about removing it. Game over, self.game over equals true. Game over equals true. All right, great. Okay. When the game over is true, then put game over in a giant font across the screen. So the question is, like, where do you put this? Like, personally, I would probably put it in the draw everything. Yeah. That's exactly where it's... So if self game over, we'll do this right at the end before we update. Look at that. Self.game over font. Yeah, but I don't have the game over font. Can you show me how to set the game over font? Oh, font. Why are you specifying it as none? Like, what's the point of it? All right, will it at least work now? All right. If self game over, screen.blit. All right. If the game over is true, then all right, let's see what happens. Like, what I want to know is, does the screen freeze? Font not initialized. I get an error. Font initialized. To initialize Pygame. Really? We didn't initialize Pygame? And oh, we did. And we sent it. So you need to initialize it first before you set the font? Bruh. Let's try that. All right, nothing to do but try to die and see what happens. Great. Okay, so let's make this, I don't want to describe it. It's faster to do than to describe. So we find when we game over this thing, right? So it's going to blit that. I'm just going to time dot sleep. 5 seconds will do. And then self.game on is full, so it'll probably close this window. The only other thing that, one thing I could do to improve is kind of set the, no. It appeared after? I thought the blit updates it. Maybe I need to update the display here. Here we go, here we go. The whole dying part proved to be a fair bit harder than expected. Hey, that's nice. That is very nice. Okay, 2-1, good. Okay, so now we need the winning condition. If, let's see, do we have a game1 variable? Yay! If self.game1. I mean, I can just copy this, really. If self.game1, we could say you win. Color could be green, not red. Or blue. Make it blue. Oh, yeah, blue, whatever. 255. So it's going to say you win. Center of the screen, display update, game on is false. But we need a condition when we win. And the question is, where do you put it? I think with the game logic, before we draw everything, the whole update business. Yeah, like here. Do we do a function? Def. Fine, do it. Check. Win. Self. There you go. And so we can put the check win in the big run thing, draw everything. There you go. So I now gotta kill 10 guys, which is fair enough. Should be fun. And I've decided to just add some difficulty escalation. Okay. With a little bit of difficulty escalation, this could be just beautiful. Beautiful. All right. So let me get rid of all these comments here and let me think just for 1 second. What's the best way to do this? So for enemy and enemies, right? The idea is, if there is a spot where you can update the score, it should be where just something that happens once, like where the score is iterated. We could change the enemy speed for all the enemies. Let's see where it's set, first of all. Enemy speed is a constant here. And the enemy speed is created where the enemy is created, which is going to be here. Actually, the enemy speed is set inside the enemy object that's not even touched. I don't think this is used at all. Why did we create it? Okay. Now, what is the best way to update the enemy speed? Update enemies. For enemy and enemies, enemy.move. Okay, in enemy.move, we can actually set speed. And self.y could be the parameter of this speed. And when we're doing the enemy.move, we could make that, create some equation here and make that sort of a factor of the score. So the basic enemy speed is 1, I think. Was it? Okay. Now we can make that enemy move thing 0.5, and we can add. Ha! They're faster with time? Nah. We're gonna make it a function of score. So if the score is 10 times 0.5 maybe plus self.score over 10. So it will be initially 0, but when we get 10 out of 10, it'll be 1.5. Or what if it's 1 plus self.score over 10? Oh boy. At 2, they're going to be pretty quick. Let's see if you can feel the Excel. Oh. Self.hero.move. That's ridiculous. Control C. Self.hero. Did I actually change the hero move? That was the hero class. That's silly. Self.y speed. Okay. Never mind. We wanted to move the enemy. That, comma, speed. And that was just going to be speed. And inside here, update hero and arrays. Update enemies. For enemy and enemies, enemy.move. Enemy.move 1 plus self.score heck over 10. Is it going to bother Pygame whether we use what kind of division it gets? It just worries me a little bit, because what if Pygame receives like a fractional value? If it receives a fractional value for a pixel, is it going to crash? This is going to be all good. Is it crashing? No, it's not. It's surviving the fractional values for pixels. And here we are then. This is legit. They're getting quicker. I think I can go one higher. I think I can go one level higher than this. What if we went up to 20? And self.score over 10, the top speed was 3. Or even if we accelerated this, no, self over 10 will do. And we'll try to get to 20. Okay. I might actually cut this into the beginning of the game, the intro to the video. This should be a challenge. Are they getting quicker? I think they are. I think they are. But so am I, actually. I'm getting a lot of practice. Every 2... Oh! They are getting quicker. $20. Winnable. You guys can keep tweaking it to try to get the level just right, where it's really, really hard to beat. But I am pretty happy with this. This is 53 minutes. And that's a fairly advanced version of Space Invaders. While I play this, let me just recap my overall feelings with Copilot Chat. Look, I honestly think that I'm going to be coding with Copilot Chat every day. I think VS Code is my editor of choice. It is not half as good as GPT-4, but it's like 10 times more convenient. And because it's 10 times more convenient, it's probably a better choice. So if you can get it for free, or if you're going to pay for some AI assistance to your coding, I think this is the way to go. I also am convinced it's only going to get better. There isn't a lot of information about the model used here, but I imagine it's a fine-tuned sort of GPT-3 model. And I mean, right now, the way that it's able to answer questions and sort of figure out what you're asking for, go into your code, find the files. It's like, it is so much more convenient than pasting code into ChatGPT. So yeah, I think we're looking at the future here. It's still a bit worrying the way that it constantly hallucinates stuff and then puts in functions that do not exist. GPT-4 does not do that. But I think that is a problem that, OpenAI and GitHub and Microsoft, I mean, at this point, there's 3 companies involved in this thing. I think that's a problem they can fix. So yeah, I recommend you guys jump on board. This was a fun experience, even though I had to do it 3 times. 3rd time was the charm. That's all, and I will see you in another video.